So this answer sheet is on Edmodo. So if I go too fast, that's why, because you can still go back. There are notes all throughout my study guide that you may look at. I'm going to try to do one of each type so this refreshes your memory. And if you have questions, please ask. Alright, so we're going to do one of each type of these. I'm just going to use the table. I'm just going to do exactly what we're doing for our trig stuff. Remember that for exponentials, we start our x's with negative 1, 0, 1. And the original y's for this function would be if you didn't have anything else, the minus 4, the plus 2, you would be putting these into x. So it would be 3 to the negative 1, 3 to 0, and 3 to 1. That would be your original parent function table. And we're going to apply these two transformations to it. Add 2 to our y's. Do the opposite to your x's, so add 4 to your x's. So 3, 4, 5 are now your x's. 2 and a third, 3 and 5 are now your y's. Plot those 3 points. Right. For this, for your exponential functions, not your log functions, your asymptote is dependent on whatever your vertical shift is. So there will be an asymptote at y equals 2. And you're going to go towards the asymptote and away from it. What would your domain of this function be? All row numbers. Your range? Y is greater than 2, not including the 2. So this is an asymptote. For your y-intercept, you can put 0 in for x and figure that out. So 3 to the negative 4 plus 2. What is 3 to the negative 4? Just 1 over 81. You can either make that a mixed fraction or find out what 2 would be with the same denominator. I'm not going to do that for time purposes. Our asymptote, y equals 2. And then our end behavior, as x goes to negative infinity, y goes to 2. As x goes to positive infinity, y goes to infinity. So this is going to be on the short answer piece. Non-calculator short answer piece. Questions on that? Now let's do one of our logs. So remember that the logs and exponential functions are inverses. So our original table is going to switch Now our y's are going to be negative 1, 0, 1. Pretend that it was base 1/4 raised to some x power. So our x would now be 4. This next one is 1, and then 1/4. They just switch places. Then go back and apply those transformations. You have one outside, one inside. So you are adding 1 to your x's and adding 1 to your y's.
Are you okay?
So your new x's are 5, 2, and 1 and 1/4. Your new y's are 0, 1, and 2. So plot those 3 points.
Say it later.
Remember, for your log functions, your asymptote is vertical, but it's dependent on whatever is inside. So if your entire function was shifted right 1, your asymptote is also going to be shifted right 1. So your asymptote is now going to be at 1. So this is going to go towards your asymptote, up, and then away. What would your domain of this be? X is greater than 1. Your range? All real numbers. This is a typo. I should have said x-intercept, not y-intercept. Your x-intercept is actually in your table. 5 zeros.
It's vertical.
If it was not in your table, you would need to set up your log function as an exponential. Yes. Yes, it should say x-intercept, not y-intercept. Your asymptote. X equals 1. And then your end behavior is going to be different than what it was before. X doesn't go to negative infinity, it only goes to 1. But as x goes to 1, y goes to infinity. And as x goes to infinity, y goes to negative infinity. Questions on that one?
I know. I have recorded this today, and I'll do an A on it. Because I realized it.
Alright, we can do 2 of these if you would like. We're definitely going to do 5. Do we want to do another besides 5?
Yes, so we can just get the
7. Okay, so we can do 5 and 7.
7 was kind of good.
Oh yeah, number 7
So with these problems, you need to remember all of your log and exponential rules. How can we combine them? Can we condense them? Can we expand them? Can we rewrite them? what can we do when we're adding? What can we do when we're subtracting? All of those rules. Alright, so here we have the same base. We actually have the same base all over the place, but we'll talk about the one on the right in a second. When we have the same base, that means we can condense these two by doing what? Multiplying. I'm also going to rewrite this because any number in front can be raised as an exponent, rewritten and raised as an exponent. Now, there's a rule that states if we have the same base, we can drop the exponents, and that's basically what we're going to do here. We have our same bases, so I'm going to drop my logs and just use whatever is here. So now we need to solve for x. And then move these over so that this equals 0. And then factor quadratic formula, however you do that. I'm going to use the AT method, so two numbers that multiply to be 80 but add to be 2. I think that was 80. 8 and 10. Negative 8 and 10. And then I'm seeing what could I factor out of each set. So 8x and 2x. I'm sorry, just 2. Sorry, 5. I don't know why I said 2. Where did what come from? These two combined equal 2. You're looking for two numbers that multiply to be negative 80 but add to 2. Everything on the outside would be one factor. Everything on the inside is your second. Solve both for x. And then I put a note on my study guide that if you were putting both of these back into the original because it had logs, remember you can't have logs of negative numbers, only 1/2 would work. So really, only 1/2 is your answer. Questions on that one? Remember, if they have the same basis, you can drop the exponent and set them equal to one another. You can solve this one of two ways. You can either involve logs, but first see if you can change the basis to be the same. So this has a couple different things going on, so I'm going to do this a little separately. I'm going to look at just these two. Could I change both of these to be the same base? To what base? 3 to the negative 3 for this one. And then 3 to the negative 4 for this one. So remember, you need to know your exponent rules. I do anything else, now I'm going to look at this 243. Can we change that to be the same base as well? 3 to the what? 3 to the 5th? And then your exponent rules say that if you have the same base, you can multiply everything together. But when you do that to your exponents, you're multiplying your exponents. I'm going to do this one first. And then here, because you have the same base, you can add your exponents.
Is that 5K?
Yes, minus 5K. I'm writing really sloppy today. Oh, I think.
All of it.
That's okay. But yeah, the 20 minus 4. So now that we have the exact same base, I can drop my bases and set my exponents equal to one another. So negative 9K plus 6 equals 16 minus 5K. So if you have the same base, you can drop them, set your exponents equal to one another. And then solve for K. I will say that's not the answer I originally got, but it's because I think I did that wrong the first time. So I think when I did not do I did the wrong order. My order of operations, I did my exponents here instead of my parentheses. Yeah, because you should have got 4.
Whoa.
I'm going to go back to this step.
Oh no, wait, this is.
Yeah, I'm
You did
going to
it
go back to
wrong.
this step and fix it.
It's okay. Everybody needs some sleep. Me. And I can't do my test.
Just like
That's not funny.
That's
a good example. That's a pretty good example.
What did you say? I missed it.
No.
Wait,
She
it
missed
doesn't.
it, she
It's
missed
not
it.
the same. Say it
I know, but
twice.
I want to hear it.
No, you
She was
missed
like,
it.
everybody
Nah,
makes
nah.
mistakes, including me. I turned you guys just blank, so.
Oh yeah, me too.
Bro,
Let's go.
this is not good.
Still got A's though.
So
I don't.
I didn't do order of operations.
Okay.
Parentheses before exponents. I did exponents first.
Yes.
So here I should have did these two before I did.
I only got 1 F.
Oh.
So combine these two.
Wait, I'm so. So what are you?
Okay.
Okay. No. Oh no.
Before you do the exponents.
That makes sense.
I like this.
Not 10.
Wait, can you go up just a little?
To which part?
She doesn't believe. She shouldn't believe.
Oh, so what you did was you did -4 plus 5.
Yes. That's what I should have done the first time, yes.
Oh, okay. It's not answer on the answer key.
Wait,
Yes. What were you confused about?
tell me how it's doing it.
Oh, yeah.
Oh yeah, so it should be 1/4.
Okay.
It's okay, Miss Stork. Good mistake, Captain Jericho.
I was just confused. That was on accident.
No, that was right.
Let's go.
Very nice.
Oh.
Very
Thank you. Sorry.
All right, so we're not going to do each of these applications. We're definitely going to do the one that not everyone, but mostly everyone missed on the original test.
Catherine.
Wait, are we gonna follow this one?
Mostly
The single soul better,
for
right?
this, yeah.
Okay, that makes me feel better.
Okay, so for this one, I think the problem that everyone was getting confused with is that this says in thousands and this says 5,000. So when this was originally set up, everyone did this. But because this says in thousands, these two numbers need to match. These either both need to be in thousands or they both need to be a single digit because it's represented in thousands. Not one of each. So I'm going to change this to say 5.
Wait, why?
Wait, explain why.
Because it's in thousands. That implies already. So if I put 5 there,
So
that
like
really means
it's understood.
5,000.
So you also could have set that at
'Cause it's like
8,000?
when
Yes. You could have done either one. Yes.
But you could have made the
8,000.
But don't do that. That's too much.
You get the same answer either way. I think on my answer key I did it both ways. So now we're trying to get t by itself, so we need to multiply this entire denominator to 5. From here you have two different options. You can either start this by dividing by 5, or you can distribute. You will get the same answer either way. Same amount of work for both. Doesn't matter. I'm going to distribute because I like to distribute. But if you wanted to divide, that's fine. We distribute it.
Oh.
We're still trying to get t by itself, so get everything away from t. Correct. And divide by 15. I divided by 15.
Okay.
After this, we have to get rid of e. How do we get rid of e? Oh, by taking the ln of both sides.
Yes!
Gosh, we're gonna have a calculator, right?
Well, yes, this you have to.
Do you know what LN equal again?
ln and e cancel. Your base gets brought down. I'm sorry, your exponent gets brought down. This becomes ln of 1/5.
So this is not an exponent anymore.
It is not an exponent anymore.
Oh, so it just comes out.
This is getting a little
drops. Nothing else happens.
Yes. So really what happened is this came out to the front, but these canceled. So there's nothing, it's not multiplying to anything. It's not in front of anything.
Someone want to do that? Intellectually?
I don't have the facilities for that.
I think when you get it, you should get 2.29. So about 3 years. Is that what this is? Yeah, years.
We can round out.
questions on this one?
Was that round down to 2 years?
So we're not running down because that wouldn't make it to 5,000 fish. If we round it down, it would be less. So we need to round up. Yes.
Maybe
3 years. Do we need to do another one? Okay, we're gonna do 9.
On the test, no, you can go. On the test, will that part at the top be given?
It will be given to you. Yes.
So you don't have to memorize those formulas?
I would so, but it will be given to you.
It's pretty useful.
Alright, for this one, you need to know important words. So initially purchased at this, after 7 years, it was worth half. You're looking for the rate of depreciation, so it's decaying.
But wait, Miss Thorpe, is it gonna say like it, on the test? Is it just gonna say like right continues to decay? Because I feel like it didn't say that. It was just like you had to figure it out.
Yeah, it would probably you have to figure it out.
Okay, so like when you just like be like since it was like going down by a half,
It was
then
decaying.
it was decaying. So how do you know the difference between exponential and continuous?
It would say continuous.
It was.
Alright, so for exponential decay, we're going to use this. So whatever it was initially, this, oh, it is, sorry, I misremembered. So it's not this, oh, this one is not on here.
Yeah, it's the other one.
It's basically the same, that's an A, not a 9. But it's negative R.
Yeah.
So that was one of my notes to add onto that if you were looking at my notebooks.
Negative R.
Yes, so it's basically the same as this except R is bigger.
Wait, R into your foot?
No, it's just negative.
Oh, negative
Are
R.
we looking
Are
for
you
the
writing
rate?
this stuff?
Say that again. We are looking for the rate. So because it is worth half of its original price, we know that it is going to equal half of this. The end amount will equal half of this. What is half of this?
22,500.
Okay.
Very nice one.
So we need to solve this for R. You should be at the same level, I just can't write.
Is that 22,500?
No, it's a 7.
There were 2 questions I was just asking, I didn't hear either one.
22,500.
This is your end amount, and it's half of the original.
Oh.
Logan, what did you ask?
It got it.
So to solve this, divide. And then we need to get R1 out of the exponent and by itself. So take ln of both sides. And divide by -7.
What happened to the big numbers?
Yeah.
We divided.
We divided them. They went away from
Come on, guys. I got it.
But we divided this by this.
Yes.
Do you just automatically put the negative with the number? Like when?
Yeah, because it's multiplication, I could say it's really 7 times R. I'm sorry, -7 times R. It doesn't matter.
Okay.
That's why we can divide both at the same time. You get some decimal. So So that would be its rate. Remember what you're looking for. This one you're looking for the rate. So it's depreciating at 9.9% each year. Yes. Was it more than 0.99? Was it more than 0.99? Okay. If it was, then yes. Okay. Do we need to go over anything in 4.1? Converting radians to degrees.
Wait, not all.
So 4.1. Yes. Okay. 4.1. Yes or no?
What's the one that's like?
No, but I didn't tell you what about 4.1. Okay, that's 4.1.
Wait. What month did you do this in? Like, how long has this been quartered and gone? Right.
Oh, I don't know. Before winter break, that's that much.
Forever.
Now we can do 4.2. Sure.
Oh yeah, let's do 4.2.
Isn't it just that?
Just the angular and linear speed.
What?
Yeah.
Isn't it that equation? 4.2 set equation?
Yeah.
Equals 1/2 something.
Yeah. 4.2 is different equations. It's arc length, area, and your angular and linear speed.
But yeah, that was kind of.
Okay. What we don't get through today, I need you to come see me today after school to ask questions, or tomorrow morning before we take the test to ask questions.
Oh man, the test is tomorrow.
It says this morning.
What the heck?
Oh,
It's not like it says on the board.
We seriously don't listen to this class.
That thing was so fucking
Well, man, that is your fault.
Yeah.
Why is the test tomorrow?
Oh yeah.
Because the quarter ends Friday.
Why is
Seth.
the test tomorrow?
That's Wednesday if the quarter ends Friday.
She's giving us 3 days to do it. You could just
Oh,
not
yeah,
take
I
it.
should do it.
I guess.
You
could just choose
That
us
is a
there.
good thing.
You all are silly.
All right. So with these problems, you have to do your linear speed before you do your angular speed. Remember, linear speed is your s over t. Angular speed is your theta over t. In order to find this, you need to find this first. But in order to find your arc length, you need to find theta. In order to find theta, we need to take our revolutions and multiply it by 2 pi. In this, I did not care if you, this part. I did not care if you multiplied pi in or left it out. For arc length and area, you need to multiply pi in. Yes.
So when you multiply 1,040 by 60, it says per hour.
I'm going to do everything step by step. So if you want to do that first, that's completely up to you. Where you did your conversions didn't really matter as long as you got the same answer. Okay. So we have theta. We can now find S. Except we need to know that this says diameter, so this needs to be cut in half. So R equals 38 centimeters. So we're multiplying 38 and 2400 times pi. Again, if you included pi, or if you didn't, you may get 2 different answers. For this one, I didn't care.
It'll be the same answer if you just read your pi.
Oh.
Yeah,
You get
but like
one pi
she
and
has
how
no
high.
answer. So if you do pi or if you leave it out. She would have done it wrong.
I was looking for what S was. 91205. Our V is then S over our T. But this is in centimeters per minute right now. Right now this is in centimeters per minute. And we need it in centimeters per hour.
So 60?
So we're multiplying by 60.
And over 1. I'm just too dumb.
So that we can get centimeters per hour.
I know.
We're multiplying by 60.
It's like how you do it in 10.
Oh, yes, got it.
If you've done 10. Have you done 10 kids? So you remember those, right?
No.
You don't remember those?
Oh, yeah, I remember.
For the moles.
No.
Pretty freaking good.
If you multiply pi in, you get 17,907,000. I messed it up. 17,190,795 centimeters per hour. So it'd be a lot bigger.
That means she has
Now to go back and find our angular speed, we know we need theta, which is found right here. Right now this is still per minute. And we need this in radians per second. So we need to divide by 60 to get this in seconds. So 40 pi radians per second, or if you multiply pi in, 125.66 radians per second. Remember, angular should always have less steps. We needed this. Questions in 4.3. I know some of you haven't finished that section yet, but that's just your using your trig on your right triangles.
For this one, when you do formula, do you include pi in the
If it says round.
Okay. So we multiply that pi in that? Or no?
Yes.
Okay.
In what?
8 over 1 squares are all the squares.
Do one of them.
I don't know. I was
Multiply this by 180 over pi.
Can you do that?
I'm going to simplify this without dividing everything out. So I know 9 goes into 180 20 times. I know these pi's cancel. This is 40 degrees. I definitely put 40 pi on the study guide, but it's just 40 degrees. Okay, so for this section, I realized that everything that we've been doing, the direction said give exact value, and then on the test it said give the reference angle and the exact value. So if you didn't give the reference angle, I didn't take off for that.
Oh wait, I didn't talk about I was like,
So just to refresh your memories as to what that would have been, your reference angles are in the first quadrant. 0, pi over 3, pi over 6, pi over 4, pi over 3, pi over 2. Those are your 5 reference angles, and pi is negative. So your reference angle would have been pi over 3. You need to know that 5 pi over 3 is in the fourth, which would make it negative. What is sine of pi over 3? What is the sine of pi over 3? No. Root 3 over 2. So the sine of 5 pi over 3 would just be negative that. But again, if you knew your values, I gave you credit for that. If you knew it was negative root 3 over 2, that was fine.
so that's just the
It's just
Whatever
circle,
from the
boo.
unit circle. Yep.
You just gotta leave a circle. But you don't, so.
yes I do.
Yeah, bro.
I'm gonna go cry.
What did you do on this section?
Watch me.
She's gonna go.
I'm not gonna watch
He's
it.
so rolling.
And then on her private story, I'm gonna see.
Okay, this will be the last one we do together. For 29, this is asking you to find the rest of these values. We should be able to find sine without doing any work because it's just a reciprocal. Now this has all 6, so I'm just gonna re-put sequence.
Wait, okay, so like this makes sense to me, but like on the test it was like negative like the square root of 10, and then I just didn't know
It's the same process. It's over 1. Tangent is positive here. So secant is negative in the third and in the fourth, but if tangent is positive, this can only lie in the third. That means everything except tangent, cotangent has to be negative. And you need to find your values. You also need to remember your hypotenuse or your radius, however you're setting this up, cannot be negative. Your radius or your hypotenuse cannot be negative. So that means even though there's a negative out front, it has to go with y.
It's not hard. You know, it's not hard. Listen, it's not hard.
Oh, she's doing the okay. I know what you do. Remember how like triangle thing and how it's and then she changed this to actually so you just do that and you do that like that.
Because I
did.
And you just go back.
Also, some of you were putting this as a negative answer, and that's not right.
Miss Dorsey,
Yes.
how do you know which one is negative?
Radius and hypotenuse cannot be negative.
Right, it's not that. Got it. Why?
What is that? 24. Some of you also, when you got to this point, did not simplify. You needed to. I can't leave this as a square root of 24. I need to simplify it. 4 and 6. Right? And then you would need to remember your x over y y over x, all of those things to figure out which ones are which. Some of you switch some of those up, which mess those answers up. Right? If you have other questions, you need to come see me after school today or tomorrow before school.